positioned. Transmission, the extension housing, that's actually bolted on. The transmission extension housing are all completely together. And then I put the Dana 300 on top of it. Okay, we're cutting off the stub. This is on a table saw, and no, this is not safe, or the safest way to do this, for sure. I've got it tight between here, and all I'm doing is rotating it a little bit at a time, pushing it a little bit further, rotating a little bit at a time, and I'm trying to cut down into it until it's almost through. I don't want to cut all the way through because then it can chuck. So well, very impressed with the cut. I was able to get it basically flat and square all the way around. This is the machine surface. I put it against the area I just cut. It's a nice fit. Step one. So I cut that off. I cut through almost all of it. I left just a hair, and then I broke it for safety's sake. Like I said, I didn't want the saw catching it and flinging it. Put it back in the jig, moved it over, and cut off another, basically perfectly square, flat section that now has this cut down to just the bottom of where the oil seal would sit. So I can put this on here, and then I'll have an oil seal right at the end, and it removes just enough material that this will now fit inside the back of the Dodge 4x4 extension housing. We've done a lot of research on welding with aluminum bronzing rod or brazing aluminum rod, and what we're going to use is, we have a commercial. This is a commercial hot plate, 1500 watts, 1500 watts, and it should has a regulator. It's supposed to be very good, but you could probably use any one. But the idea is that aluminum dissipates heat very quickly, and trying to get the surface and keep the whole thing hot is going to be difficult. So we're going to use this and hopefully get this almost up, if not to temperature. This, I'm not sure, but this may be strong enough that if we leave it on there, it will hit 700, which is what it needs to. And what we have is, here's the both pieces. We've wire brushed them. We'll wire brush them again after as they heat up. Properly center them, and then I'm using a piece of ceramic tile. I may cut this down so it fits just around this edge on top to hold it. I'll put some weight on there, and then I can come underneath and just touch the seam with the rod. And the game plan is, you see there's a fraction, a small portion of difference. So that's going to be the lap area. And I'm feeling very comfortable doing this too because of these ridges. So if we go in and we go around the ridges, that should really provide an extra support. And again, the only thing that this piece is going to do, technically, is just hold the bearing in place. The bearing will press inside here, so it'll hold the bearing in place, and that's all it's for. It doesn't support the shaft, so this should be more than adequate. We have the heating plate. We have the heating plate with the flange, the cut piece, and the other flange. And sorry about all the smoke. There's stuff burning off of the heating plate. On top of that, we have a small piece of ceramic tile. And on top of that, I've got a gear and another metal weight, hoping to press all this down and keep it tight since I can't clamp it. We also have a digital thermometer, and right now this is up to 5. The plate is hitting 600, and I've still got a lot more to go on this plate, so I'm thinking we can probably hit the 700. The aluminum is up to 400. So we're letting this cool down now. We had to use the MAP gas. I had it on low setting, and between the heat plate and the MAP gas, the heat plate kept the flange hot. So once I got it, but it wouldn't heat it all the way up hot enough, so I had to use the MAP gas. But then it was just a case of walking around with the stick and wetting. You really have to rub with the stick, and that's why I put the weight on, so it would stay in place. Well, I did a little bit of rubbing to get the that first layer of oxide off. Even though you've cleaned it, there's still going to be a little bit of chemical oxide. Once you do that, then it cleans up. It puddled in spots, you can see that. There's spots where it wetted really nice. But we're going to grind it down and clean it up and see what it looks like. We're just about done with our adaptation project for the Dana 300 to the rear of the 46RE extension housing. This is our plate we made. This is out of 1/4 inch thick aluminum T61, and we cut the outside, drilled the holes to match the spacing of the holes on the Dana 300, and cut out the inside. This is our modified input stub that we cut a section out of and then aluminum brazed it back together again. And this shortens it considerably. Not enough that we could get away without using this spacer. We still needed the spacer. This could have been shortened more, and you could, but then you wouldn't have enough room for the bearing surface, though there is room inside that this could have been modified. We could have built that up or welded this back in here. But then we had a problem with the stub shaft, or the shaft coming out. We would have had to cut that off more. So we felt this was a good enough compromise that adding this much to the rear doesn't add that much more to shortening or lengthening drive shafts. And we're going to try and position the transmission in the Scout so that we don't have to modify the drive shafts at all. That's the intention. Now this is it's actually a press fit, very tight fit. And while these bolt holes will hold this in position on the Dana, and these holes with the studs will hold this ring in position, and this surface, part of this, will fit inside the rear of the 46RE, again, we wanted to make everything as tight a fit as possible, with removing as much play as possible, is a better way to say it, possibility for play, so that since these are aluminum, they don't wear, and so that the drive shaft and the transmission are immobilized as much as possible, except for what they're supposed to move. I have the plate, the spacer on the Dana. I have the input snout, and I have it tightened down to the Dana, and you can see that that's the amount that's going to stick into the extension housing on the, this is the amount that's going to stick into the extension housing of the 46 RE. I have the bolts in to make sure that everything will line up. Since we chose to keep the spacing backward of the transfer case to the end of the transmission, we had to shorten the shaft. And what we're doing is we're using cutting oil, of course, a reciprocal Ryobi, battery powered, and the newer Diablo Demon carbide tips. This is second blade. The first blade was the thicker one. It was the amped, and that actually, I think, cut a little bit slower, or maybe it was just because we were cutting across the big part. But once we cut through and we weren't cutting full bore, we're able to start cutting through, and we're almost all the way through. Just got a little bit left, see right there. And that was, we're still using that blade. So we might have been able to cut the whole thing with this one blade, but in any case, that's what we used. And we put a rubber piece with a clamp on it, so that I could have a straight edge to use. And it's not perfect, but it's you can see from the rubber that we've got very close to a straight edge all the way around. We're going to grind the end anyway. We're going to put a bevel on it, like on here. And if this comes out right, so we should have nice engagement, full engagement of the splines, if all of our measurements are correct. We finished sawing through, and it's a pretty square cut. Let's see if this is still, I can touch this, yeah. Okay, so this is what we sawed off, and you can see I left, didn't hit the teeth. I cut ahead of the teeth so we wouldn't hurt those splines. Now I'll have to take this hose clamp off and then bevel the edge. This is our modified input shaft going into the Dana 300. The end that goes into the 46RE extension housing used to be 0.57 longer than this. Cut it off with a carbide saw, and then ground the last little bit, because I didn't want to cut too close to the beginning of the splines and possibly mess them up. So I cut fairly close, and then I ground down the rest to get almost to them, but still leaving a little bit. And This will give us full engagement. There's still over 2 inches of spline material in there, and it fully engages on the splines of the extension housing. And this goes into the modified special adapter we made. Unfortunately, our local shop, the person who does all the machine work, press work, had a back surgery, and so nothing's being done. Could have gone somewhere else, but what I ended up doing was I have a 12-ton hydraulic pipe jack, and I got some angle iron. I made stops, and I used it to press the bearing off and press a new one on. We were making the gasket, the cork gasket. This is 1/16 of an inch thick, using Felpro's little kit and a box cutter knife that we sharpened. And we use a little hole punch for these. You can use drills, but then they get really, you don't get nice clean edges. Not that it really matters for these holes, they're not oil, but still, we like them to be fairly clean. So I think I have a hole punch for letters that should work. I'm using actually a socket to punch the holes out. This is a 9mm, and you see it has actually nice sharp edges on it, taper. And by just placing it over where I want it and hitting it with a hammer, I'm able to cut out a nice circle. It does a really nice job of cutting it out. And there we have a finished gasket. Looks pretty decent. And this is what it looks like on the adapter we made. One of the changes we had to make was the seal that goes for the front input shaft. This is a replacement. This is the correct one, or the original one, and this is the one that we used instead, or had to use instead. The outside diameters are identical, but the inside diameter is, let's see, do it this way. The inside diameter of the second one is larger. Also, it has the rubber around it, and it has a different type of lip on it. It's a double lip. It's really made for wheel bearings and stuff. And it's got a little bit of spring to it. And the reason we had to do this was because since we pushed the shaft in so far, the seal, this seal wouldn't fit. It would ride up against it. So we put this one in. Also, with this being rubber, it mates against the seal coming out of the rear extension housing, and so you have a seal to seal, or this seal sealing against the other seal, like this, basically. And so then you've got that really nice double oil retention, one for the transfer case and one for the automatic transmission fluid in the and since both of these are actually inside the airspace between the two cases, if there's any leak at all, it's going to come down and go out that little leak in the bottom of the case. And this is what that seal looks like installed. Against that one right there. at the rear extension. And there's the drip hole between the rear extension and the transfer case. Shaft and the bearing in the modified input. And if I put this on the trans, go down all the way, you can see that that's where it bottoms out, and that's why I need the spacer. And again, to back this off with the spacer and backing this up 1/4 of an inch, or just about 1/4 in that, that gives me my couple thousandths clearance that I want between the end of this shaft and the end of the shaft and the output. Ring goes around like that, and if I bring this up so that it's flush, it's still engaged in this housing. So this housing is around this, and the bolts will be here. It'll be a very solid fit, and everything will be aligned, centered because of that. Teeth are just starting to engage the splines. If I set it all the way down, that's 1 3/4 inches of engagement between all the way down and just starting to engage. And here's the adapter plate, the input shaft, and snap rings in, and it's nice fit. What I'm going to do though, for safety's sake, because I don't want to assemble it all and then find out I got a problem, is looks like these are okay, but I'm going to put the bolts through and tighten them down with just nuts instead of using the Dana. So I squeeze these all the way around and then make sure everything still has is free, and that it doesn't bind up when it gets tightened down, because I don't want to put the Dana on, tighten it down, and then have a bind. It's easier to work on now. In length between the stud we took out of the Dana 300 and the ones we're putting back in. Also, the Dana 300 only had 2 studs in it, and we're putting studs in all 6 holes, and we're using blue Loctite. These do not go through. These holes do not go through. These holes are through holes, so you have to make sure you seal those. But these holes for the studs are not through holes. The Loctite is in there to hold them in, and we're not trying to use it to seal, to keep any oil from coming through. Getting ready to put the input back in, and I spread Permatex Moto Seal gasket maker very thinly around this rim to mate against the back of the plate. Synthetic grease on the ends here before we slide it back inside. plate marked so I know where it goes to get on the right orientation, since they're not spaced evenly. And just slides right on. Now I have to put the studs in here. And what I'm going to do is we'll put blue Loctite near the ends, or about halfway, and then we'll put some of the gasket sealer on the last half, because these are through holes, so they could leak. So we put the blue to lock them, and then a little bit of gasket sealer just on the end of the heads right here, in case any oil gets passed. Blue on the end, and then a little bit of the gasket, gray gasket, at the other end. 6 Allens are tightened down around the input. The plate is on. We're adding the gasket, and again we're using our marks so we know the alignment. And another thing I did was just reach inside and turn this gear and make sure that the shaft turns smoothly. There's no binding. Next step is to put that on the end of the extension housing. We're probably going to do that outside, though, to cut down on the weight we have to transport, because we have to get this whole transmission, extension housing, and the Dana 300 outside and underneath the vehicle. So I'll wait until the last minute to hook this up, but we'll do it right here for a second, just to make sure everything still goes on nicely. I made marks on the top too. You can see the plate, a little bit of a gasket, and then the extension housing. And again, this is a 1/4-inch plate, and it looks really nice. Everything, there's plenty of room around everything, and as long as it works, we're great.